So today we're going to talk about simulations for autonomous vehicles, and in particular, an often neglected aspect of that simulation, which is what everyone else in the simulation who's not the self-driving car is supposed to do. So as the AV industry is maturing, we see more and more work being done in simulation. As real road testing is slow, expensive, dangerous, and typically AV companies will drive orders of magnitude more in simulation than they do in the real world. And there are some really great simulations out there. People will make faithful digital twins of relocations. They'll make a lot of assets for different road participants, and they'll ensure that their vehicle dynamics are simulated faithfully. They'll put a lot of effort into their sensor simulation. But there remains the question of what are the people around the car gonna do? And you might think, well, that's straightforward. You go out there, you record what people do in the real world, and then you play that in simulation. It's not quite as simple as that. So let me kick off with a quick example to show you why this naive approach fails. So we're going to look at this very simple scenario. The two vehicles highlighted in red are the vehicles of interest to us. So what's going to happen here is basically they want to change lanes. The top vehicle wants to move to the bottom lane and vice versa. And now what's tricky about this is that, well, there is no a priori order in which they're supposed to move. So who has to go first? And that's basically what they need to negotiate. For humans, it's very simple. So you can see that in this example, the human drivers had no issue with this whatsoever. But when you're testing your AV, you might find some issues with that, especially if you use the naive replay, like we talked about. So for the purposes of this exercise, we're going to pretend that the top vehicle here was our AV, driven by a human operator during some initial data collection stage, and the bottom car is one operated by another human driver. Right? So this is a little reenactment of this situation in Carla. So this is like an open source driving simulator. And you'll see that this is basically what happened in the real world, that the top vehicle, the AV, goes first, and then the human-driven car yields to it and then changes lanes after. All right, so now let's say we're in the situation where we have an AV, it's working, and it behaves correctly in this situation, but overall, for whatever reason, we decide that, okay, our AV is too aggressive. We want to taper it down a little bit and yield to human drivers more often, right? And now, say, this is a test case you have in your continuous integration. Now your AV becomes a little less aggressive. And what happens if you replay the behavior of the black vehicle is now the white vehicle is trying to yield, and the black vehicle is replaying, and they're just going to crash right into you. And obviously, this is a nonsensical scenario in the sense that the black car would never actually do it in the real world. But if you just run your CI with replay, you get a collision here, and you need to deal with it. Well, so really what you would want is if you use a reactive model for the black car, it's going to recognize that you're yielding, and it's going to go in front of you, and everything is good. So this is really the essence of what we're after here, is how to make the non-ego road users, or the NPCs, non-playable characters, to borrow the gaming terminology, reactive to what's happening in a realistic way. Right? So this is really what our company does, Inverted AI. So we make NPCs that are realistic, reactive, and diverse. Yeah. That's the core of what we do.